Welcome to Spring LIB.
In this question, electrical energy is used to produce a chemical change of ions in solution to their neutral elements. Given a time of 1 hour and a current of 15 amps, we're going to determine the mass of each substance produced. To solve this problem, follow these steps. 1. Determine the quantity of coulombs of charge that pass through the solution. 2. Determine the number of moles of electrons which was required to carry that coulomb of charge. Thirdly, we're going to write the half reactions. Then, determine the number of moles of substance produced. And fifth, determine the mass of this substance produced. 1 amp is equal to 1 coulomb per second. So 15 amps is equal to 15 times 1, which is 15 coulombs per second. So total coulombs of charge is equal to 15 coulombs per second multiplied by time. Time is given as 1 hour. You need to convert hours to seconds. 1 hour is equal to 3600 seconds. So 15 times 3600 is 54,000 coulombs. 1 mole of electrons carries a charge of 1 Faraday. 1 Faraday is equal to 96,485 coulombs. So therefore, 96,485 coulombs is equal to 1 molar of electrons. So therefore, 54,000 coulombs is equal to 1 divided by 96,485 coulombs multiplied by 54,000 coulombs. And that is equal to 0.56 moles of electrons. So therefore, 0.56 moles of electrons flow through the aqueous solution. So now we are going to go through part A. You're going to produce cobalt from cobalt 2. This is an aqueous solution and this is a solid. This carries a charge of +2. This cobalt is in its neutral state, so the oxidation state is 0. To balance this equation, the cobalt 2 cation needs to gain 2 electrons. So each cobalt cation requires 2 electrons to become a cobalt atom. So 2 moles of electrons produces 1 mole of cobalt. Therefore, 0.56 moles of electrons would produce 1 divided by 2 multiplied by 0.56. This is moles of cobalt. And that is equal to 0.28 moles of cobalt was produced. The molar mass of cobalt is equal to 58.933195 grams per mole. So therefore, mass of cobalt produced is equal to number of moles, which is 0.28 moles, multiplied by the molar mass, which is 58.933,195 grams per mole, and that is equal to 16.5 grams. Therefore, 16.5 grams of cobalt was produced. Now we're moving on to part B. We have hafnium ion and produce hafnium metal. To balance this equation, hafnium cation needs to gain 4 electrons to become a hafnium atom. So each mole of hafnium ion requires 4 moles of electrons to become a hafnium atom. So therefore 4 moles of electrons produces 1 mole of hafnium. Therefore 0.56 moles of electrons would produce 1 divided by 4 multiplied by 0.56 moles of hafnium, and that is equal to 0.14 moles of hafnium was produced. Molar mass of hafnium is equal to 178.49 grams per mole. Therefore, the mass of hafnium produced is equal to 0.14 moles multiplied by 178.49 grams per mole. That is equal to 24.99 grams. Therefore, 24.99 grams of hafnium was produced. Now moving on to C. We have potassium iodide. It should be noted that neutral elements have the oxidation numbers add up to 0. Potassium is a group 1 element, so its oxidation state will be +1. And for the total oxidation number to be 0, the oxidation number of iodine needs to be -1. So I minus would produce I2. Right? So we need to balance this equation. On this side, there's one iodide atom, and on this side we have 2. To balance this equation, seeing that we have 2 on this side, we multiply the left by 2. So to determine the number of electrons which needs to be lost would be equal to 2 electrons need to be lost to give iodine. So loss of 2 moles of electrons would produce 1 mole of iodine. Therefore, 0.56 moles of electrons would produce 1 divided by 2 multiplied by 0.56 moles of I2. And that is equal to 0.28 moles of iodine was produced. As before, we're going to determine the mass of iodine produced. So we need the molar mass of iodine. And each iodine atom weighs 126.90447 grams. So therefore, we multiply by 2 because we have 2 iodine atoms. And this is equal to 253.8089 grams per mole. So the mass of iodine produced is equal to the number of moles, which is equal to 0.28 moles of iodine multiplied by the MR, which is 253.8089. This is grams per mole. And when you do the multiplication, the result is 71.07 grams of iodine produced. And lastly, we have chromium trioxide was produced. So we need to remember the rules when it comes to oxidation states. So oxygen has an oxidation number of -2 except with hydrogen peroxide and with fluorine. Seeing that this is not hydrogen peroxide and there is no fluorine present, the oxidation number of oxygen is -2. And you can see we have 3 oxygens, so the total is -6. So in order for the oxidation number of chromium trioxide to be 0, chromium, the oxidation number needs to be +6. So the half reaction is as follows. You have Cr6 plus, you need to gain 6 electrons to become chromium solid. Right? So this means that each chromium ion requires 6 electrons to produce 1 chromium atom. So 6 moles of electrons produces 1 mole of chromium. Therefore, 0.56 moles of electrons would produce 1 divided by 6 multiplied by 0.56. This is moles of chromium, which is equal to 9.333 by 10 to the -2 moles of chromium was produced. As before, we need to figure out what is the molar mass. So the molar mass of chromium is equal to 51.9961 grams per mole. So therefore, the mass of chromium produced is equal to 9.333 by 10 to the -2 moles multiply by 51.9961 grams per mole. And that would result in an answer of 4.84 grams of chromium was produced.